All right, so today what we're doing is we're going to go over just your basic differentiation principles. So I'm going to do this in a couple different videos just to keep them short and sweet so that you can watch the ones that you need. So this is just an introduction to the basic differentiation principles. So what I want to do is I want to give you an example. And what these are, the word differentiation is the same as derivative. It's the action of taking the derivative. You're going to differentiate, or it's differentiation. Those all mean the same thing. So remember, whenever you see or hear the term derivative, differentiation, differentiate, all that means is you're finding the slope. You're looking for the slope, but now remember that h goes to 0, so now you're looking for the instantaneous rate of change, or the instantaneous slope. In other words, what is happening at a particular point? Okay, so it really helps us to focus on what's going on. So as a business owner, which all of you guys are going to be, as a business owner, what you're going to be able to do is, let's say you're looking at the profit across, a year's time. And you can see that your profit goes up and it goes down and it goes up and it goes down. Hopefully it will continue to go up. It won't continue to go down. But what you can do is you can find, well, how much did the profit change at a particular point? So for instance, if you had a profit that dropped, you want to know why. You want to look at that particular point, find out exactly how much profit changed, how it changed, and then why. You're going to look around it. Remember that idea of limits coming, that what approaches a certain value. So let me just show you. I'm going to go through the definition of a derivative very quickly. You're going to love me from this point on, because after this lesson you're going to be able to use these, what we call shortcuts. But I want you to see that you're doing the exact same thing. All right, so here's our function. We have f of x equals 2x squared plus x. Okay? This is our function. It's a parabola. We know it's a parabola because it has x squared, so we can kind of have that in our mind. We know on a parabola that we have a slope that goes down. It hits 0, right? 0 is a horizontal line. And then it switches. Something happens right here where our slope or our rate of change goes up. So that's always a good idea to know what your function is going to look like. So now I'm going to use the definition of a derivative. So remember, the definition of a derivative is the limit as h goes to 0 of my function, okay? And we're going to work it out. So, oops, sorry. I was getting ahead of myself. So the definition of the derivative is the limit as h goes to 0 of f of x plus h, minus f of x all over h. That's our definition of a derivative. So I'm going to use this, okay? So here we go. Every time I see an x, this tells me to replace it with an x plus h. So I'm going to come in, and then this tells me to subtract off my function. And then I'm going to divide the whole thing by h. And it is the limit as h goes to 0. Okay, so now here's your algebra skills. I'm just going to work it out. We know that x plus h squared will always be x squared plus 2xh plus h squared. If you don't remember or don't believe me, you're going to take this and multiply it by itself and then use FOIL to distribute that through. So we have 2 times x squared plus 2xh plus h squared. That's that part. Plus x plus h. Now I'm going to push this negative and change both signs. Okay, so it was positive, now it's negative. This was positive, now it's negative. All divided by h. Now I'm going to distribute this 2 through every single piece. So I end up with 2x squared plus 4xh plus plus 2h squared. And then continue all over h. Now I get to cancel. So I have a positive 2x squared and a negative 2x squared. I have a positive x and a negative x. So what's left are only terms that have an h in them. And that is by design. Okay? So now I'm going to factor out my h. So remember, when I factor h out of h, I end up with 1. Now I can cancel my h's. So my derivative is, let's see, how do I want to write this? So my derivative is 4x plus 2h plus 1. And then the limit as h goes to 0. So that means this dumps out to 0. So my derivative is 4x plus 1. Okay? Now, you can see it's a lot of work, right? You do not want to have to do this every single time I give you a function. So we've come up with, not me, somebody much smarter than me came up with derivative rules. Things that do the same thing, right? It creates the same thing, but it's a much shorter aspect or a much shorter way to do it. Okay, so I'm going to erase all of this. I'm going to keep the derivative. I'm going to keep my function. And I'm going to show you very quickly how I get my derivative. Now, there's different ways to write derivative. So the one that you're going to see me write the most is f prime. Okay, so it's got a little tick mark there. There's also one that looks like this, d dx. It just means find the derivative in terms of x. This is a verb. This is an action. It's a set of directions. It says find the derivative. This one, dy dx, says the derivative of y in terms of x. This is a noun. This is the derivative. Okay, so this verb and noun thing, you think, wait, this is a math class, not English. It actually comes in handy. The verb tells you to do something. The noun says this is what it is. So this is one way to write derivative, f prime of x. This is another way, find the derivative. This is another way, here's the derivative. And then if you're looking at it in terms of y, it's just y prime. Okay? You'll see me write this for the most part. It's just a shortcut. It's just notation. That's that idea of math is a foreign language, so you're just writing notation. So I stick with f prime, but you will see it written other ways. All right, so how do I go from my function to a derivative in one step? Well, there is a technique called the differentiation principle, and this is called the power rule. Okay, so what you do is you take your exponent, you drop it to the front and multiply, and then you subtract 1 off of your exponent. So 2 minus 1 is 1. So I have x to the first power. Okay, drop it to the front, multiply, and then subtract 1. Drop it to the front, multiply, then subtract 1. So we're going to do the same thing. This is an assumed 1. I'm going to drop it to the front and multiply, and then I'm going to subtract 1, do it in red, subtract 1, okay? So 1 minus 1 is x to the 0 power, which equals 1. So I have 1 times 1, which is 1. Well, look at there. In one step, I was able to go from my function to a derivative using the power rule. Okay, so let me show you in general what you're doing. So you have a function, ax to the n power. Okay? The derivative, so this is just the general power rule. This is what we call the power rule. Okay, the general power rule is you drop your exponent to the front and multiply, and then you subtract 1 off of the original exponent. So this is a general format. Drop it to the front, multiply, subtract 1. Drop it to the front, multiply, subtract 1. That is the power rule.